Well, welcome back to the lab. As in the last video that I recorded for the 7826 plug-in, this is my Type 106 square wave generator. It usually hangs out right there where that hole is. So, no eBay box, no nothing this time. This is actually one of my pieces of gear. This started giving me a little trouble, especially on the amplitude control. So I figured I'd take it down, at least open it up, take a look at it, see if it needed cleaning, see if I had to go through it for any reason, and see what it needs to give me another 50 years of service. So all this really is, this is the predecessor to the PG 506 calibration generator. All of this functionality is in the PG 506. Adjustable square wave amplitude output, fast rise and fast fall ports. Also wanted to see if I could update this at all. These are GR874. I couldn't remember the number. But this is my 874 to Bnc adapter. So one of the things that I actually like about the GR connectors is they're, unlike Bnc, they don't have a male-female connection. They're exactly the same, and they just plug in. One just mates 90 degrees from the other, and they're just in. So same thing for the fast rise. They're exactly the same there. The bad part is if you're trying to design small equipment, they're big. So, but I also want to look at the feasibility of possibly, I haven't really looked inside this yet, but the feasibility of updating these to Bnc connections, because all of my gear in the lab has Bncs, so if I can get any of these to Bnc, that would be ideal. Going to clean the controls while I'm in here. These pots are, like, that's kind of stiff. That one's okay. The plus amplitude is stiff. The amplitude is right around there. It's kind of crusty, which might be where some of my noise is coming from. The symmetry one hasn't seen much use, so it's fine, but these three need cleaning. Also going to clean the switches and lubricate these, get those all squared away. We'll take a look at the caps, see how I got 1, 2, 3, 4, 5, 6. Let's see what else we got. 6 big filters to test and go with there. The one caps that I am absolutely not going to mess with are these steel canned capacitors. These are timing caps, so they're not filters. They typically don't go bad, and getting the front dial to match up, if you can't find these again, these are very specific, very unique part numbers. Only change these if they've grossly failed. If they haven't grossly failed, don't mess with them. Also check this guy out, see how he's doing. Clean the switches, clean the pots. Let's see, what else do we have? So these are the 5 filters I'm curious about, plus this guy. Here's the frequency switch control. This is the amplitude control. This is the symmetry control. This device is 1966 origin. It's a very unique device because it's actually a mix. We've got vacuum tubes, or right here, these are all vacuum tubes. And we've also got transistors. So there's a transistor, got a couple of more transistors down there. So this is an interesting mix of tube and transistors in this particular unit, which is one of the reasons why I like it. This is put together like a Swiss watch. I mean, when I flip this over, you'll see what I mean. Ceramic substrate wafers. This uses the same build process and build procedure than a 500 series scope does. I mean, look at the bus rails just underneath the vacuum tubes. These are all bus rails. I really hope I don't have to touch anything in here. I don't want to disturb this if I don't have to. On the other side, we're starting to see a bunch of the transistors. So this is tubes and transistors in the same unit. Here's another one of the filters. This is the one that's sticking up here. This is part of the ceramic substrate wafers. Most of the business end is on the other side of the chassis. These are the, I don't think I'm going to be switching some of these out to Bncs. These are the fast rise inputs, plus and minus. So those will probably stay as GR8 connectors down here. So see how that goes. That's an interesting transistor. Look at that. The legs come out of the transistor and go to the board, but the transistor is embedded in the board. Right here. That's the top of the transistor. Never seen that before. This guy right here. So that's kind of interesting. See how that goes. Obviously, this is the business side with all the passives. Rectifier, 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 rectifier. So it looks like we're individually rectifying the supply rails. A couple more caps to test. The main output connector, however, looks like I might be able to switch it over to a Bnc, so that'll be nice. We'll see how that goes. This is going to be an interesting challenge to get under here. This is the bottom side of the 5 filters from up top. This rail will come out, so I can pull this rail off to make some room. However, gonna have to work around these rectifiers, getting down to those. This one doesn't look too bad. These two don't look too bad. Getting down to those two is going to be interesting. But these are the ceramic substrates. This unit's been off for days, so it's all the caps are discharged. It's safe to touch. We'll check the fan, grease that if it needs it. Here's a good side shot of the ceramic substrate. Somebody didn't clean that one. This is actually the first time I've been in here. So this is what the ceramic wafers look like. These are very they're very fragile to shock, but they're really solid. So you typically won't have a problem with these. The important thing about these, and all the manuals that I've read on these, do not use leaded solder on these. These have a silver content in the horseshoe in here, that if you use leaded solder too often, you'll actually break the silver to ceramic bond, and then the connection will just be floating in there. So do not use leaded solder on these ceramic strips. You'll ruin it. You have to use silver solder. Usually there's a roll of silver solder in these things. If somebody hasn't been in there yet, there may not be in here. There is in the scopes. I've pointed that out in a couple of the videos. I know the 576 still had it. So, but to do the work on there, I've got lead free. So we got 96.5 tin, 3% silver with a 0.5% copper. So this is the solder that I use for the ceramic strips. Seems to work okay so far. Haven't had a problem with it. If anybody knows if I'm using the wrong stuff, please let me know in the comments. I definitely want to know I'm using the right things. So yeah, that's a quick overview of the next challenge for the bench. I'm going to order up some more of those circuit boards. These look like the same size caps that are in the 576, so I'm going to order some of those capacitor boards that I used in the 576. I got to order a stack of those because I got another 576 I have to do, and I have order boards and get those in so I can get the other 576 rebuilt. I have no idea what this cap does in circuit, but I'll zoom in on it. Right here, this guy, right here, I got some corrosion coming off of that cap. So this cap is leaking electrolyte for sure. Okay, so we will take a look at that. Like I said, the thing is built like a Swiss watch. Let me show you the underneath the vacuum tubes because this looks really cool. It's just these bus rails with the components diving down to the vacuum tube sockets. So that is super cool. So yeah, I probably got my work cut out for me with this one, especially with these caps having the lids over top of them, but we'll come up with a game plan. What I might do is I may attack them from the top, pull these out, and then get at them that way. But we'll see how that goes. I want to be as, given the age of the equipment, I want to be as least invasive as possible, but still get the job done. So, all right. Well, that's the Type 76. I think that'll be the next thing we tackle on the bench because I'm going to need this for what's coming. I will get started on here, and we'll see what happens. I'll bring you guys back when there's something interesting going on. Okay, just a quick update while I wait on the UPS man to ship in. This is where I had to take the whole front off of the unit. Sometimes you get into these things a lot further than you mean to. So this is the unit with the front panel taken off. Removing the front panel exposes 4 screws on the back of each of the GR jacks. In looking at this, I have not figured out a good way to get these 2 GR jacks to be Bncs, given that the fast edge boards actually terminate directly into the port on these, so I think these are going to have to stay GR. However, the main output jack for the standard waveform looks like I'll be able to change that. It just had a wire going into the back of it, so the way I'm going to do that to give me the cleanest build is I'm going to get a panel mount. I'm going to get some steel that's the same size as this external, as this bracket. I'll tap these holes out to whatever this screw thread is, reuse these screws, but then it'll be a flush steel plate that I'm going to center drill for the Bnc connection, 50 ohms. I've got a tap coming, which is what I have to wait on for the thread size for the Bnc connector. So I'll thread it for the Bnc, but then I'll put the ground and the gas tight washer on there to get a good connection. And essentially the way it'll look is it'll have a Bnc dead center in there. So a good way to envision this is it'll have a Bnc just sticking out, centered on that plate, and then you'll just see steel behind it. So with the cover off like this, I wiped it down with alcohol, cleaned it up, got it looking nice, got it dusted. So I've also started planning my attack for these capacitors. This guy's going to come out, these 3 are going to come out, and these 2 are going to come out. I'm not going to mess with anything like here. I've got all the switches cleaned and serviced. Lubed the fan bearing while I was in here. Everything's clean. Chassis looks really good. The vacuum tubes are okay. A couple of tubes up there. Cleaned the controls. Got everything ready to go. And everything's looking good. So just got to keep moving. When I get that, the next shot you guys will probably see, this plate will be in. I've got more of those capacitor adapters on order from PCB warehouse or PCB fab, so getting those fabbed. I ordered something like $90 worth because I got a bunch to do in here. There's 1, 2. I will actually probably have to design PCBs for the smaller ones. The 2 large ones I can use the same PCBs that I used in the 576, but I ordered a couple more units because I got a box in from eBay, which will actually be the next restoration project. I will be perfectly honest, I got overexcited on that one, and I turned it on just to see what would happen, and it's a great candidate for restoration, but it is going to need some work. So I've got that coming too. It will be another scope, and it will probably be the last scope that we do, the last 7000 series scope that we do on this channel, because this particular 7000 series scope, it's the last one I'll need. But yeah, I won't spoil anything in the but I'm actually excited about that one. So we got that going. Everything's all cleaned up on here. Everything's turning nice. All the contacts feel good. Everything's good. So it's moving along. I'm gonna order up some capacitors. I'm going to be doing a more than a little in-depth capacitor replacement. Nothing in this unit's actually bad. However, I want this to be its last service for the long haul, so some of the electrolytics are going to get replaced even though they're not bad, but because I'm starting to see some corrosion on some of them, so they're all going to get changed. But I'm hoping that that is my last service on this for the long haul, and this thing will be good for longer than I need it, and somebody will be able to inherit it. Is my goal on that one. We'll see if it makes it. I don't know, but be getting some high quality capacitors for these. Get some of these electrolytics replaced, and we'll get moving. But that's where I'm at on this. Sometimes you get further into these than you expect. Yesterday, all these controls were out, so sometimes they're a little more in-depth than you plan, but in the end, I think it'll be good. When I get to it and we actually start working on it, I will be going in on how to solder on this ceramic strip safely, so you don't crack the ceramic strip or break the silver to ceramic bond. I've already gone into the special solder you need to use in this video, so we should be good. Fan's in good shape. I'll clean the blades a little bit, but other than that, it's okay. But once I get the caps replaced, I will get the service manual out to figure out the adjustment points. However, on this particular unit, I've read through the service manual once, and it's a little strange. It calls for a lot of zero beating. The waveforms with time channel with radio and a few other things, and the calibration process on this is interesting to say the least. But the calibration process when this was built, scopes weren't near as good, and we didn't have frequency counters with 9 to 12 decimal places on them, so some of the timing adjustments that needed to be done when this thing was manufactured in the late 60s were interesting to say the least. We have the benefit of a frequency counter, and we have 100 megahertz scopes. I've got up to a 500 megahertz scope if we need it for this, for wave shape and things like that. So, but that's the fastest scope I have in the lab. Actually, that's the scope I used in the last video. The 7904 is the fastest scope I have in the lab. So, but we'll just do a direct calibration on it. We won't need to do a lot of the convoluted adjustments because the gear wasn't sensitive enough or fast enough. So the modern gear definitely makes it easier. Yeah, looking forward to getting this done and figuring out exactly how these caps are going to work. Neat thing about that is once I get the adapter boards, I can start working on the caps. I don't even need the actual caps in because the caps solder onto the adapter board. So we'll get that done. I'll get some electrodes ordered up, and we will continue on with the restoration. But everything is going well at this point. Just figured I'd give you guys a heads up and let you know what's going on. All in all, this is a nice unit. I like it. So I will be back. I'll have to wait a couple of days through the magic of the camera. You guys are going to see it in the next shot. Okay, I've made an aluminum plate to fill the gap in the hole, so it's going to pop in just like that where that old connector was, which will give me the standard Bnc. I'll have the GRs for the fast rise, which is fine. I just couldn't find a way to mount because of the circuit board mounting to the back of the connector. I couldn't find a way to do that cleanly to where I'd like and not potentially spoil the rise time of the inputs, so I'll still use a GR to Bnc on that one. But for now, brand new Bnc. We used some Tyco Bnc jacks. Made sure to stay with the 50 ohm, not the 75. That way we don't have any reflections because we are dealing with square waves, so there is high frequency content. Got that. I'll finish getting this installed. It's just going to solder on the back because of the cable. And then I will go through and find out what capacitors I need. Once I find out what capacitors I need, I will order some of those up. The boards are still coming in. I still don't have the adapter boards yet, but we will see what's going on there. Everything is, all the controls are cleaned and serviced. So actually, once I get this screwed in, I can put the front panel back on, put the knobs back on, make this thing look right. Yeah, that's where we're at. And next up, we will have to heat up the soldering irons and actually work on some of the electronics on this one. So I will do that, and then I will wait till I get those parts in, and then I'll bring you guys back. Alright, sorry for a little bit of the background noise if you can hear it. I've got the air handlers going for the soldering iron, and I've also got my spectrum analyzer doing a maintenance burn, just keeping the capacitors fresh in it. It hasn't been on in a while, so it's just running in the background as well. Here's the plate that we added in, and there's the Bnc jack. I've soldered I've redone the lead wire to the Bnc, so that's all. That looks good. I've got the front panel back on. All the knobs are in the front. One of my problems on this one is I have two different sizes of capacitor. There's a small capacitor, which is right here, and then there's a larger one, which is hiding under these. These are actually rectifier packs in this one. So full wave rectifiers, or full bridge rectifiers. So I've got 4 can style of the smaller ones, and I've got 2 of the bigger ones that I need to do. There's 3 of them. 1, 2. These 2 are going to be fun to get to. They're going to take some work, but we'll get them. The other can is right here. So this is actually what one of these cans looks like from the top side. So I'm going to pull him off, and I'm going to pull him out and make sure they're the same size physically. And I'm going to work on designing an adapter board to get them working with the new style capacitors, because I can get replacement can style capacitors that'll sit here. They are very expensive for what they are, and they're also not as good. I have not seen any of these can style capacitors that are higher than 85 degrees C rated. So all the stuff that I've got coming is 105 degrees C, modern stuff. So I'd prefer to use that, especially with a line of vacuum tubes in here. This is going to get pretty hot. So actually, this is a nice mix of unit. Here's a line of vacuum tubes. Here's a line of transistors. But I'd like to get the capacitors a little bit higher temperature. The other caps that I have to deal with are these. These are just axial leaded. These won't actually be too bad to deal with a modern replacement. So should be good. That's where we're at on this so far. Now I'm just going to pull this guy out and this guy out, and then do some design some boards. So I will get that done, and then I will be back. All right, we've got the one test capacitor hooked up to the meter. This is a 550 microfarad capacitor. My ESR is okay, 0.06. That's actually pretty good. But it's reading high on capacitance. Capacitors, especially of this time frame, typically are not overachievers. When you see a high capacitance, they are usually leaking DC, so they're taking longer to charge, which is tricking the meter into thinking that they have a higher capacitance. So it's a good thing these are coming out of there. They are faulty. Not really faulty, just aged out. I'll continue working on the board, get that all going. We'll get these swapped out, and then I'll bring you guys back. Well, it's a good thing DigiKey packs their boxes correctly. This is as delivered. I no idea what happened to this thing in transit, but it has seen better days. However, the capacitor shipment is in, so I have the various caps I needed for the 106. This box looks like horrible, horrible damage. The only real damage to the capacitors is these little kinks in some of the leads. So with this much damage to the box, actually not much happened that I need to be too worried about. Got a couple of different values. The nice thing about DigiKey stuff is they pack them in these. This is packed up and it's top and bottom, so everything was pretty well packed, which is good because this box took a pretty decent hit. So there we go. So I'm going to reposition everything. I'll pull this back into the shot. I'm going to work on this capacitor back here so you guys can see what I end up doing. But the rest of the replacement will be the same until I get to the bulk filters, so I'll just film one. However, before we get started with the repair, we have a new soldering iron sponge. One of the reasons you do need to use a water to clean the soldering iron tip when you do this is going from leaded to unleaded solder, because I got to work on the ceramic tie strips. Definitely unleaded solder. That'll be this stuff. But I got to clean the tip of the iron really, really well, get it all cleaned up, and get it tinned with unleaded solder, and get all the leaded solder off so we don't break the ceramic strip. All right, we have our soldering iron heated up. I'm using a medium width tip with a reasonably hot temperature. It's 750 on the iron. This is a fresh. I'm going to clean it off on the sponge first to get it really clean. I use a fresh brass. This is my lead-free brass wool. I don't have much there. Just going to do some tip tinning real quick. I have the fume extractor going on pretty heavy due to the fact that I have found lead-free solder smokes off a lot more than normal solder. So, or normal 60, what is it, 60, it's not 60-40 anymore. I forget what the percentages are, but the leaded solder, the flux is a lot more smoky in the lead-free, so as you can see by some of that coming off. So I'm tinning it under the fume extractor, just getting it nice and clean. I'm just going to do this. This is the third time doing this, so right back under the fume hood so it doesn't oxidize. Good, super clean tip, and immediately retin with fresh solder. Okay, now that the tip is converted over to lead-free, it's solder like normal. So what I'll do is I'll reposition the camera, give you guys a shot in here. I'll be working from up top, and we will do this 1 microfarad capacitor in the back. Okay, the target capacitor we're trying to replace is going to be this guy right here. This is a 1 microfarad, 150 volt. I have 1 microfarads, that's 100. 1 microfarad at 450 volts. Let's see. There's a size difference, just a comparison. So it won't lay down in there. It'll pop up just a little bit, but it'll be fine. Also, we have a cap that's 4 times the voltage, so that will be fine as well. Okay, so to get this out of here, we're going to add a little bit of solder to the iron. And then we're going to come in on the side with a joint. Going to heat the joint. just lift it out. Do the same thing on the other side real quick. Now you do need a reasonably hot iron for this due to the fact that the dwell time, or the ceramic strips, it actually soaks a decent amount of heat. So doing a ceramic strip with a weak iron is going to be problematic just because the ceramic can soak so much heat out of the iron, so it takes it a while to heat the joint up. But there we go. There's our volunteer. He's out. Everything's good. Okay, I just used a solder gun to pull solder out of the stirrup, and the new capacitor will just lay in like so. Positive on this one is that way. So negative is this side, positive is that side. So what we'll do, get a little bit of solder. Pair of flush cutters. And we just trim off the leads. And we have a replaced electrolytic capacitor. I will go through, that's just burn off flux. So the burn marks and the looking horrible is just flux residue. I will get in there and I will get that cleaned off. That looks a lot worse on the camera than it really is. But that's cleaning off pretty easy. So we're good. The saddle didn't come out, so everything's good. So I just have to do that a whole bunch more times. I won't record that, but I'll bring you guys back once I get all of those replaced. I'm still waiting on my boards from the fab for the bulk electrolytics, but I can at least get started on the smaller ones, so I can get them done. So I will get working on that, and then when I get all that done, I'll bring you guys back. Just a quick progress update. Getting the capacitors updated. These are done. These 4 are done. The 2 on the fast riser done. This guy hiding back here behind the tubes is done. Yep. Him right back there. He's done. This one microfarad cap is done. I haven't gotten to any of the large electrolytics yet. The adapter boards are taking a bit of time coming back from the fab. Not surprising given the current situation. I took this vacuum tube out so I could get better access to these boards. Didn't necessarily need to do that. It was an absolute bear to get this vacuum tube out and to get the shield off and the vacuum tube out without breaking anything. So if you can get these boards to do these two caps without taking any of these tubes off, that's the best way to go. These 4 tubes are, they all work in parallel to drive the the high amplitude square wave output. So you can still buy them. They're not horrible if these go bad, but I was seeing prices on like $23, $24 a tube. So not awful, but not cheap either. Yeah, the only thing I have left on this one, once the boards come in, is this electrolytic and those 5, the bulk filters for the supplies. So once that's done, we'll fire it up, make sure we didn't put anything in backwards. Hopefully there's no magic smoke. And we'll just take a look and then see if we have some square waves. So what I'll do now is I'm just going to take a Q-tip and clean up the ceramic wafers. So clean the flux off and keep going. But just want to give you guys a heads up as to where we were at and show you what's going on while I wait for the boards. Today's Thursday, so the large cap adapter boards, these might come in tomorrow. Said they shipped. These haven't even come back from the fab yet, the small cap adapters. So I am probably not going to be able to finish this guy up this weekend just because I will be lacking some parts. I'm willing to wait because I want to do it right. But for now, a bit of cleaning, and that's where we're at. So everything's looking good. Didn't really run into any problems last night in getting all the capacitors swapped out, so everything looked good. So when I have an update, I'll bring you guys back. Okay, I have all the capacitors switched out finally. This is going on 3 weeks worth of work. Everything up top is switched out. The little guy is switched out. Everything down here in the bottom is switched out. So you guys can see all the brand new caps there. New caps there, new cap there. The couple right there. The little stuff on the back side. All the main filters are switched out. Everything looks good. Had to take this rail off. Had to do a lot of work in this section. Getting everything squared away. Lots of parts removal, lots of parts back on, working with the ceramic strips. Everything looks good. I think everything looks good. So we haven't turned it on yet. Make sure there's no smoke. So I figured I'd do that when I get you guys back here with the camera. So for right now, I'm ready to plug it in. Turn it off real quick. Well, that's a good sign it didn't smoke out in the beginning. So now that I have it plugged into the wall, I have to be super careful I don't get zapped. The unit is upside down. So let me get a XLR, hook it up to the scope, and we'll go ahead and turn it on. Nothing yet, but it's Takes a while for the caps to warm up. The unit's drawing 600 milliamps, right around 68 watts. Square wave has just popped up on the scope. Everything looks good there. Let's see. Yeah, I can adjust the amplitude of the square wave, so everything looks good. So what I'm going to do is I'm going to unplug it. I'm going to put the face back on it. Obviously the face is off. So I'll reattach the face, put it back in its case, and then I'm just going to let it burn in for hours and hours and hours just to make sure the power supply is not going to have a problem. Nothing smokes out. If it survives that, I will do the alignment, and then it will be done and back into service. These are all 105 degree C caps, so this shouldn't need to be serviced now for another 50 or 60 years. There are warnings on, I'll cut in a picture because it's healed up. There are warnings in the front of these videos about the dangers of working on this types of equipment. Those warnings should be taken seriously. This thing bit me. My finger got stuck between the negative side of one of the cans and the ground rail on the side of the chassis, and I got buzzed through my thumb. So if you are working on these things, always use caution. I got zapped. I didn't measure it out. I'm pretty sure I got zapped by about 150 volts DC. So it did not feel good. I had burn marks on my thumb for a little while, so I'll cut in a picture of my thumb if I can find one where you guys can actually see the burn. But definitely heed the warnings, definitely use care, especially when working on this stuff. This stuff can bite you. This thing's got a 450 volt supply in it, so just take care. All right, so let me put that back all in, and I'll get all the knobs put back on and everything look good, and then we'll just let it cook. So I'll bring you guys back when it's all said and done. Okay, I have the unit back in the case and the power analyzer hooked up to it. It's feeding it. I'm going to give it some power here for a second. And we have a nice square wave on the scope. Everything looks good. Actually, my tails were eliminated, so some of those caps must have been leaky. Everything looks good on the square wave. It actually looks perfect now that it's back in the case. Front panel's back on. Everything went together real good. The switches are cleaned and serviced. So as it sits right now, I'm just going to let it burn in for the rest of the evening. Tomorrow I'll shoot the carnage shot of what got replaced all in the unit, if it survives, and after that it's on to the next project. So this is a square wave generator that should be good for another 50 years plus. So I will let you guys know if anything exciting happens. Till then, I'll be back. All right, well, I have this has been running for a couple of hours. Everything's been perfect. The waveform never fell out. The highest current it's drawn out of the wall is 106 watts. So everything looks good there, just shy of 1 amp. I checked the fast rise. Actually, I just got done checking the fast rise. Outputs, they're okay. The high amplitude output is okay. We actually see that got changed from the GR to the Bnc, so that's more useful in the lab. These I typically don't use just because PG506 does the same thing, and I actually have that tunnel diode pulsar that does the same function. Actually, it's even faster than these. But it's good to have adjustable fast rise outputs, even though I won't need them that much. So the unit's been running all night, so it's going to be a success. It's nice and warm. The case is warmed up on the outside, so everything looks good. Nothing squeaking. All the ranges work. So I'm going to call this one done. I'll get this shut down and push it towards the back of the bench, and I will get the tray of carnage, which is what got removed. So I will be right back. Okay, here's the tray full of all the components that were replaced. A bunch of capacitors got swapped out. These were the main filters for everything. These were, there's the GR connector that got replaced. I'll actually save that. That may come in useful, because if I need one of these, good luck finding one of these again. So that'll go in the parts drawer. Let's see, what else do we have? We got some generic electrolytics. This transistor went. Where's my tester? Not 100% sure what happened to this transistor and why it went, but it's dead. There's a saying, no components connected, even though something's clearly connected, so that transistor's toast. He was in one of the voltage regulator circuits. This resistor burnt in half, given the transistor dying out. So that happened during one of my interim tests before I had all the capacitors replaced, just making sure I wired a capacitor up right. So fortunately I didn't catch that excitement on camera. These were the capacitors that you can see the corrosion coming out of the end on those. So that's what kind of caused the recap, plus a little bit of the waveform looking a little strange, having that tail end at the bottom. The replacement transistors I got were 2N3439s. 2N3439s. These are the exact same thing as the 2N3940, which is what this guy is, except the 39s have a better voltage holding. This is a, if I remember the spec sheet right, this is a 200 volt transistor. These are 250 volt transistors. These are 400 volt transistors. Yeah, so that's everything that came out of that. That came out of that guy. So he's ready to go back up there so I can work on a couple of more scopes. Thanks for stopping by the lab. If there's anything you guys would like to see me work on, tackle on the bench, let me know. We'll see what we can make happen. Any video ideas or anything, let me know in the comments below. I do read all the comments. See you guys in the next video.